Moving here into section 7.1, we're going to be working with identities quite a bit in this section. Throughout all of chapter 7, really. There are all these different trigonometric expressions that we want to deal with, but whenever possible, we would like to get them into the simplest form. Really, it's just about ease of computation, and in some cases, you'll see this in, for those of you going on into calculus, there are situations where there are procedures that we want to take on, and we can't actually make them computable until we break these trig expressions down simpler. Now, earlier in the course, we have seen the Pythagorean identities. We've seen the identities involving the periodicity of sine and cosine functions, and we've seen the definitions of the trig functions. We've also seen a couple of other ones that sine of negative x equals negative sine x because it is it's an odd function, and cosine negative x equals cosine x. That one is an even function. So we'll be using those as well. There's a nice table in the beginning of section 7.1 in your text that lists all of the fundamental trigonometric identities that were mentioned earlier in the semester. But once we have those down, and there's not a lot that I tell you, really just need to sit down and memorize it, but the trig identities. Read through the proofs in the book so that you know where they come from, but these things, they do need to eventually be committed to memory. And they allow us to do things like if I was to take cosine t plus tangent of t times sine of t. Put these in parentheses just to make it clear that I've got some multiplication over there. If I needed to evaluate this, if I consider this as some function, f of t, and I needed to evaluate this at a fixed point, I'd have to evaluate three different trig functions. Plug in and evaluate here, here, and here, multiply these two together, add the result. That's a lot. Plus, unless it's one of those nice reference angles that we've got in our table, I'm going to be approximating every time I find this multiplication will be approximation, the addition at the end will be an approximation. I'm going to get pretty far away from what I'm actually looking for. But an easier way to do this is to simplify this using some trig identities and see if I can turn it into something that's a little bit more straightforward to work with, requires fewer computations. So I'm going to start out with the identity for the tangent. I know how the tangent is defined. The sine of t divided by the cosine of t. That's all multiplied by the sine. So, cosine t plus sine squared t over cosine t. Alright, that's not bad. Let's get these over a common denominator. So I'm going to have this as cosine of t. If I want it to be over cosine t, I'm going to need to multiply by cosine t up top. Still have a sine squared t over cosine t here. And combining these, I have cosine squared of t plus sine squared of t all over cosine of t. And I can take this one further. This one we covered back in chapter 5. From our Pythagorean identities, we know that's equal to 1. This is equal to 1 over cosine of t, and that's the definition of the secant of t. So we went from up here 1, 2, 3, 4, 5 operations down to just one. Much lower chance of making an error, and it simplifies the expression a great deal. Now there's only one computation instead of 5. And in addition to some of the identities that we have given to us in the text, sometimes we need to prove that an identity is true. So let's say I have cosine of u 1 minus sine of u equals secant u plus tangent u. Now I claim this as an identity. one side is actually equal to the other. And when you're being asked to prove these identities, you're wanting to substitute or simplify the expression using known identities to prove that these sides are equal. A lot of the times, and what I'll be proceeding with here, is I'll take this side and I'm just going to leave it alone. I'm just going to mess with this and see if I can turn it in to this. So if I start with just cosine of u for 1 minus sine of u, I'd like to get some terms in here with either sine or cosine squared. The reason for that is that a lot of my identities have sine squared and cosine squared in them. So I look at the denominator and I see, well, I've got a 1 minus sine. I could multiply that by its conjugate, 1 plus sine of u, and see what happens. So if I multiply by 1 plus sine of u over 1 plus sine of u, I've multiplied by 1, so I haven't changed anything. And I'm going to get cosine of u plus cosine u sine u all over 1 minus sine squared of u. That works all right so far. So what else can I do with this? We'll look at 1 minus sine squared u. Now I'll get this over here in the corner. We have sine squared u plus cosine squared u is equal to 1. So 1 minus sine squared u cosine squared u. Ah, convenient. So back to here, this is equal cosine of u plus cosine u sine u all over cosine squared of u. Oh, all right. Now I've got a cosine here and here, they're common factors, and I've got cosine squared down here. So I can cancel each of these with one of the cosines down there, and I'm left with 1 plus sine of u over cosine u, 1 over cosine is the secant u, and sine over cosine is the tangent u, and that's exactly what we wanted. Cosine u over 1 minus sine is secant plus tangent. Cosine u over 1 minus sine, follow our equations all the way through, secant u plus tangent of u. So sometimes you can prove an identity by only messing with one side, getting it to where it's going to be equal to the other. Sometimes you've got an identity where you're going to have to mess with both sides. So something like 1 plus cosine theta over cosine theta equals tangent squared of theta secant theta minus 1. And I claim these two are equal to each other. And just going ahead and changing one side into the other is going to be problematic. It's going to be easier if we try to break these things apart into their component pieces and see if we can get them to be equal to each other. So if I just look at what's on the left, 1 plus cosine theta over cosine theta will be 1 over cosine theta plus cosine theta over cosine theta. So I've got secant theta plus 1. So all I did there was I rewrote this in terms of the simplest trig functions I could. I didn't multiply or divide it by anything. I didn't really use much of an identity other than that 1 over cosine is equal to secant and that dividing something by itself is 1. So that's a nice way that I can simplify the left side. If I can simplify the right side to something similar, hopefully I can get these two to be equal. So for the right-hand side, tangent squared theta over secant theta minus 1. I'd like this to just be a secant theta plus 1. But to do that, I can try a couple of different approaches, but what seems to make the most sense to me, maybe if I can get everything just in terms of secants, that'll help. Now, from the Pythagorean identity, we have something for tangent squared. So let's go off to the side, do our Pythagorean identity again. Sine squared theta plus cosine squared theta equals 1. And if I divide everything by cosine, tangent squared theta plus 1 equals secant squared theta. So tangent squared theta, secant squared theta minus 1. Okay, let's use that. So my right-hand side over here, secant squared theta minus 1 over secant theta minus 1. Now I can't just cancel the secants here. This is not a factor of the entire numerator. Nothing is going to cancel. But I can certainly rewrite the numerator because I notice that this is a difference of squares. And difference of squares are always factorable. So secant theta minus 1, secant theta plus 1, all divided by secant theta minus 1. Now, this is a factor of the numerator, and this is a factor of the denominator. So they divide out, and I'm left with secant theta plus 1. I get the same thing here that I got up here, and my identity checks. So, as you're working through these identities, you've got a couple of options. You can either verify that one side is directly equal to the other, or you can manipulate both sides to bring them to be equal to something that they have in common. In either case, look back at the beginning of section 7.1 at that table. Fundamental trigonometric identities. We need to make sure that we are getting really comfortable with those. They're going to be important as we move through this section and future sections.